So now I'm going to tell you about the arguments of a function. Okay, we have seen already two examples with functions with two arguments, and the arguments were not of the same type, but they were quite similar in the sense that I'm saying that here in the first position I have to write this variable, which is going to be a dictionary, and here I'm using this variable, this argument, as if it were a dictionary, and if it's not, probably it's going to return to raise an error. And also the second argument in this case is a number, okay? So, and I'm going to use this as if it were a number. So if this is not a number, probably it's going to give me some error too. In this first case, we had this function EasyPlot, where I had two arguments. The first one had to be something like an array, and the other one too. Both need to have the same length, okay? Because if they don't have the same length, then this is going to give an error. It's going to raise an error saying that that these two things must be of the same length. And now we are going to see that we also are going to have other kinds of arguments. Let's see, what does it mean? So, well, first of all, the arguments of the function are the inputs that it takes to make the computations in the statements. Okay, mainly all the information should come from the arguments, not always. Okay, we are going to see that sometimes we can use another kinds of values that are not defined in the arguments, that are defined outside the function, and we can find them inside the block of code of this function. Okay, but as a useful rule, let's say that all the inputs should be in the arguments of the function, and these types of arguments can be of several types. So we may have positional arguments. Okay, these are like the arguments that we have used until now. Okay, these are mandatory arguments, and they have to be in the same position if the name is not specified. Okay, so if we have, in this case, okay, we had in any case, I have that the first argument is going to be addict, okay, and the second argument is going to be threshold. Okay, in this case, when I call this function, these two arguments, the first one is going to go with addict, okay, which is a dictionary, and the second argument is going to go for threshold, which is the value that I'm using to filter. And in this previous case, I have x and y. I'm using x is going to be the first argument, and y is going to be the second argument, just like in here. Okay, we had x, this input, this argument is called x, this argument is called y, so, and that's it. Okay, so this is the first argument and this is the second argument, and that is why they're called positional arguments. Okay, because they need to be specified when we call the function, and the order of these variables are the same. Well, is the same as in the function definition, unless we write the names of the variables, as we will see a little bit later. A second kind of arguments are keyword arguments, okay, and these are very widely used for optional arguments, and they take a default value if it is not specified when we call the function. Okay, we will see what does this mean. So in this case, we have this function over here. It's a very, very simple function. It's a dummy function, let's say. So we have this function defined with the name fun, and we have two variables which are positional arguments. Okay, these two first arguments are positional arguments, and then we have a keyword argument. Okay, and notice that we are giving this argument already a default value. So I can call this function fun with only these two variables, x and y. And I can omit this value, and if I don't write a specific value for z, then it's going to get the value of 10. So, and what does this function do? Well, let's see. We have here a string. Okay, this is a string that I'm returning, and we have the first part of the string is the value of x, so is x equal to the value of x that I have just written here. The second part of the string is y equal to the value. Okay, this is going to write the value of the variable y, which I used here as an argument, and the value of z is going to be written also, which is the value that I have introduced here, or if I don't introduce any value for z, then this is going to print z equals 10. Okay, so I'm going to call this function now with several arguments to see what it prints. Okay, let's see what happens when I call this function with the arguments 1 and 2. Okay, when I write this line of code, well, remember that if you write a string with it has before an f, this is going to be what is called a formatted string. Okay, this is a formatted string, which means that I can write the values of variables inside brackets, curly brackets. And in this case, it's not only going to print the value of x, it's also going to print x equal and then the value of x. And the same goes with y, and the same goes with z. And in this case, that I'm printing the result of this function inside curly brackets and with these spaces, okay, this is going to write all these spaces, then it's going to write this thing just like it is, and after that it's going to write the return value of this call, okay, of this of this value that this function returns. Remember that it returns a formatted string, so it's going to write also a formatted string. Okay, so now I call fun1, 2, and I obtain, remember that in this case x is 1, y is 2, and since I don't give a value for z, then the default value that this function is going to take when I call it with these arguments is going to be 10. So what it writes is going to write x equal 1, y equal 2, and z equal 10. Okay, and this is precisely what it returns. Okay, x equal 1, y equal 2, z equal 10. Now, the second time that I call this function, notice that the way I call this function is slightly different, although the values of the arguments are the same. The arguments are still 1 and 2, but notice that I have specified here x equal 1 and y equal 2. So I'm saying that I'm going to take this first argument. In this case, it corresponds to x, but just because I'm writing here x, okay? In this case, I'm writing y. Okay, this is going to correspond to y because I'm writing here a y. But if I change the order, like in this case, then the result would be the same, although I'm changing the order of these variables. And why is that? Because I'm saying that now y is 2 and x is 1. So these three calls should return exactly the same because I'm calling them with the same value of the arguments, although the way of calling this function is not exactly the same. I'm writing here x equal 1, y equal 2, which is the same as this call, which is the first argument, which is x is 1, and the second argument, which is y, is 2. And in this second way, what I have here is y is equal to and x is equal 1. And it doesn't matter since I have named the arguments, okay, since I have named these arguments, which are the same names that we have here, x and y, now I can change the order of these arguments, of these positional arguments. So positional arguments are mandatory arguments, and we will see now in a few minutes what does it mean. But these are going to be in the same position if name is not specified. So if the name is specified, then what we have is that we can change the order of these arguments. Now, we are going to call this function, but now with values of z. So now I have in this call, I'm calling y equal 2, x equal 1, and now z equal 5. Now let's see what this function is going to do. The values of x and y are going to be 1 and 2, just like before, and now z is not 10 anymore. Now it's going to be 5, because I'm calling this function with z equals 5. And that's it. So if I call this function this way, the result should be x equal 1, y equal 2, and z equals 5. And that's exactly what it returns here. Okay, x equal 1, y equal 2, and z equals 5. And here in these two other calls, the result is going to be exactly the same. And why is that? Because I have changed the order of the arguments, okay, but I'm still using this. I'm specifying here the name of these arguments, so I can change the order of these arguments as long as I specify the names, okay. And in this case, the result is the same, because x is still equal to 1, y is still equal to 2, and z is 5. So here we have the second call. Okay, this would be the second call. And in the third call, we have exactly the same. Now, the keyword argument is at the beginning, and then we have the arguments of y and x. And the result is the same. Okay, and I forgot to add here one of the ways of calling this function, okay, which is, let's see. So what I'm going to do now is to call this fun, but instead of using this these named variables, what I'm going to do is to use the positional arguments, okay? Well, not only the positional arguments, but the position also in the keyword argument, because this keyword argument is in the third position. So if I write here 1, 2, and 5, the result is going to be the same. Okay, and this result is going to be, yep, here like that, here like that. So the result is going to be exactly the same. Okay, here is the first 1, 2, 5 is just like the rest of them. Or if I write here x equal 1 or y equal 2, and I again compute this. Hello, positional argument follows keyword argument. Oh my god, I forgot this. Yes, I'm using these are keyword argument because I'm specifying the name. Okay, so even though they are defined as positional arguments, but I'm using this 5 over here, which should not be used after keyword arguments. So in this case, this is wrong. So the only way of calling this function with no keyword argument in the 5 is if I call the two previous ones, if I call them without the keyword, okay, without the name of the variable. I forgot that. Yeah. Okay, and now the last example that I was explaining to you is this one that I wanted to explain. Okay, I'm going to obtain the same as before, and notice that here in line 18 I have an error. Okay, and it's going to be a type error, and it says fun, which is the function, okay, the function fun, missing one required positional argument x. And that is because I'm calling this function with only z and y values, but no x value is specified here. So I obtain an error, because remember that positional arguments are mandatory arguments. So if we don't specify this positional argument, it's going to return an error. Okay, in this case it's a type error, the kind of error that we obtain. Remember to always read the errors when you obtain some error in your code, because errors are going to tell a lot about the problem that you're having in your code. So in our case here, I'm going to change the function EasyPlot that I had before, and instead of just having x and y as arguments, I'm going to add some keyword arguments. So the keyword arguments are going to be x label, y label, ls and m. Okay, and let's see what it says here. Easy a standard plot of x, y with default values of access labels. The default values are x and y. Line style and marker, and line width equal to 3. This means that the default values are for the access labels, which in this case are x and y. Okay, the line style is going to be ls. Line style stands for for the style of the line. So by default it's going to have no line, okay, no line, but we can specify a line style. And also we have the marker. Okay, the marker is this one. And in this case we don't have a line width, okay, a keyword for the line width. No, this is hard coded, okay, and this is what I mean when it's hard coded. Here I have the line width equals 3. It's when we call the plat function. And in this case, we are saying that whatever the arguments that you have here, the line width is always going to be 3. Remember that you don't have to specify ls or m, and if you don't specify these elements, then the default values are going to be no line style, okay, like no line, also only marker. And this is going to be the marker that is going to be used if you don't specify a marker. Yes, and the label for the horizontal and vertical axis are going to be x and y by default, but you can change them. So I made some examples. So I'm going to call this function EasyPlot, and with some examples. I'm going to use the same two variables x and y that I defined earlier. So these x and y are here. These are the x and y variables, okay? These are arrays, NumPy arrays. Notice that here I had a function with these arguments, but these arguments, the value of these arguments they have nothing to do, absolutely nothing to do with the values of these x and y variables, which are defined outside the functions. So these values remain even when I call these variables x and y. So we don't have to be afraid that these variables are going to change in value or something like that. No, if they are arguments, it's okay. They just new variables with these names inside this function. Okay, outside the function, when we return the value and we are again outside the function, the values of x and y are going to be the previous ones. Okay, so in this case, yes, this was one of the examples. So we had x and y. Remember that this plot was made with x and y. Remember that by default is going to use these x and y labels, no line style and dot marker, okay, a small dot marker. And now I'm also going to plot z. Okay, z now is going to be this value over here. Okay, so this is a numeric value, and this is something that depends on x. So the result is going to be a NumPy array with the same length as x. I'm going to plot this, but in this case I'm going to use a line style, which is a normal line, and no marker. So this is what it plots. By default, the line width is going to be 3. So notice here that we have a quite thick line. And that's it. This is what it does. It plots first xy, and then it plots xz. And since I'm not defining a new figure between these two calls, then it's going to be like if we were using contiguous plots. Remember that if you use contiguous plots, you are going to obtain the several lines in the same figure. So that is what is happening here. We have a first plot with the dots, then the second plot with the line, and all of them in the same figure. Here in this example, I'm calling this function, okay, now with x. X is the variable that we defined before. Now np.log x, so this is going to be the natural logarithm of this x array. Now I'm going to use a dashed line with a style, a line style of dashed, okay, and no marker. So this is what we obtain in this case. Okay, this is the logarithm when we plot it. And notice that at the beginning, it's just something that to comment on the data. Okay, so notice that here we have this same function, but we added some standard error. Okay, some standard error, I mean some standard normal error. And that's it. And this is without any kind of random variable added. So in this case, what I'm going to do, I'm defining a new function which is going to, since I'm defining new easy plots, notice that the value of the variable easy plot is going to change. So once I have defined this easy plot again, now the previous easy plot is like deleted. Okay, I cannot access this function anymore. This original function, I cannot access to this function unless I rerun this piece of code again. So in this case, I redefined this variable, okay, this function, and here in this case, I'm also redefining this function. This is a little bit more sophisticated. Let's see. And now you're going to see how these other types of variable work. Okay, there are some tuple of positional arguments, which are usually defined with an asterisk and arcs, okay, and they can be an arbitrary number of arguments, and are accessed in the function like a tuple, okay. So inside the function, if we have an argument that is called like this, okay, asterisk arcs, then we can access the values of these arguments using, like, if arguments was a tuple. Okay, so I can compute length arcs. I can access the values of arcs using this tuple or list-like way of calling. Okay, and that's it. We are not going to use a lot of positional arguments. Okay, a tuple of positional arguments. If we need them, we will I will explain you how to use them, okay, but it's not, it's interesting, and if you need them in the future, maybe you can look for information about them. Okay, we are going to see this other kind of arguments, okay, which is a dictionary of keyword arguments. So this is basically this is usually defined with this notation, okay. So this notation, if we write this in the argument list at the end of the function, these are always defined at the end of the function, okay. So we could write here in the end something like this, quarks, and then we could access to this new argument. Okay, now I'm going to explain you in another example how to use them. So in this dictionary of keyword arguments, which is usually defined by this way, with this notation, or maybe with double asterisk and then kw instead of quarks, it will be with only the kw, because the rest it's understood. Okay, so this is going to be keyword arguments, and they are optional arguments. Okay, they all are optional arguments, like the keyword arguments, but in this case there is no specific name. Let's see. Okay, so we have to see if we want to know if some keyword is in this list, then we have to look for it. For example, if we want to look for a keyword in these keyword arguments, if we want to look for a keyword which is called mode, then we would have to use something like this. Okay, if mode in quarks, etc. So I'm going to write an example of that. And I forgot that functions may have no arguments at all. So in that case, you only have to write the function without any kind of argument, and that's it. Or maybe you can, with no arguments defined in the function, So this function can only be called without any argument, or you can define with optional arguments, and you can call the function without any argument, but it's going to take some default values, okay? But let's go with what I was talking about, which are the dictionary of keyword arguments. So in this case, in this easy plot, the last easy plot that I'm going to define is going to have these keyword arguments, okay? So now I have a function with this going to have these two positional arguments, okay? It's going to have these keyword arguments, all these keyword arguments, which are related to the labels and to the limits of the access. And then in the end, it's going to have this Quarks dictionary of keyword arguments, okay? Let's see what it does. Okay, this is the way of defining a docstring with all the specifications in the parameters, okay? And in this case, it doesn't return anything, but if it returns something, we would have to say also we would have to write returns and then specify what it returns and the type of what it returns. So in this case, I'm going to explain a little bit about this docstring. So first, I write a very small summary of what this function does. Okay, it's easy, a standard plot of xy with default access labels and legend. Great. And now I'm going to say a little bit more specifically what it does. So the function plots y against x with the following options. And then we write parameters, okay? And when we write parameters, we have to write this way, okay? This is a standard style for Python documentation, and it's the one that is using NumPy, for example. And it's widely used. So in this case, I'm saying, first of all, x, y, they are array-like parameters, okay? And the definition of what they do, well, this is the data to plot, y against x, okay? Now, the other arguments, x label, this is a string and it's optional. So the x-axis label, the default value is going to be x, the string x. This y label, okay, this is another optional argument, it's going to be a string, okay, and is the y-axis label, the default value is y. And well, I forgot to write this xlim and ylim, okay, I forgot them here because I think I appended them in the end. So in this case, it should be something like xlim and ylim. These are not optionals, these are going to be two-element list like, okay? Or and it's or none. And it's optional, okay? So in this case are the limits of the x-axis. Of the horizontal axis. No limits by default. When we take the none argument, okay? So this is going to be like this. And the second part, well, it's precisely more or less the same, but for the y. So this is going to be of the vertical axis, and that's it. Okay, and then we have the Quarks argument, okay, which is the dictionary that I was telling you. Okay, now we have this optional keyword argument. Yes, so these are the keyword arguments to be passed to the function plt.plot. So if label keyword and also if label keyword is in the arguments, then it writes a legend. So what does it mean? In the first line of the function, I'm calling the plot function of matplotlib with x, y, and also with all these keyword arguments. Remember that the keyword arguments of the plot function were some of what I have used here, okay? You can specify the line style, you can specify the marker, you can specify the line width, and many other things. So in this case, I'm quite constrained by these optional arguments, but I cannot change anything else by default in the plot function. In this case, I can add here any arguments that I want, any keyword arguments, optional arguments of the plot function they are going to be applied here. So these are going to be these. Where are they? Yes, they are going to be like these arguments over here. But here I should write exactly the keyword of these optional arguments. We will see them in a minute. So if we call the plot function with x and y as arguments to plot, and then the keyword arguments for the style of this plot. Then if xlim is not none, then it's going to apply some limits to the horizontal axis, and if ylim is not none, it's going to apply some limits to the vertical axis. And if then we are going to plot the labels of the horizontal and vertical axis, and then in the end notice that since now I'm looking for a specific argument in this list of optional arguments, so if label, if this key in this dictionary, because this is like a dictionary, if this key is in this dictionary, then what it's going to do is to plot a legend. Okay, so let's see, after I have defined this function, let's see how it works. So I call EasyPlot with xy, I call the with label equal data, then ls equal nothing and marker equal dot. So in this case it's going to be a lot like the first plot, but in this case I'm specifying a label, so I'm going to obtain a legend. Notice that here in this case I didn't have a legend. Okay, so I don't know exactly what these two lines mean. I call lines to these dots because they're using the same function, okay, which is like a line, but in this case with no line specified, okay, but this is like lines. Yes, so in this case I'm specifying a label for using a legend afterwards, and I can also call again this function with x and z just like before. Okay, we have some now I'm going to call I'm going to label this plot with linear, because here I'm using like some kind of linear approximation or whatever. And now I'm going to use this kind of style, okay, a dashed line with no marker and a line width of 3 points. And this is going to be, okay, since I have a label in at least one of them, I'm going to generate a legend. So this is going to be the legend of the second plot. And now I'm going to generate the third plot, which is going to be the plot that I did in the last case. Okay, it's this one, but with a not a dashed line. Okay, so in this case it's going to be a normal line, and we are going to plot the natural logarithm of x against x. I'm using this label log x to specify what I'm using, and I'm going to use a plain line, okay, with no marker and with this line width, and it's going to use the default color. In this case, since I'm not specifying the color, it's going to use the default color in the plot. So the default colors of Matplotlib right now, we have first this blue, okay, then we have the orange, and afterwards we have the green. And if we continue to plot more lines, they are going to appear more colors. I think that by default we have a maximum of 10 different colors, and then they repeat again. So, well, this is the result, okay? So this is what it does. Notice that these values are not specified in the like the keyword arguments, okay? These are not standard keyword arguments for optional values, because if I don't write these values, I'm not going to have in my function any default value for these arguments, okay? I only have default value for x label, y label, xlim, and ylim, okay? In this case, notice that I'm not specifying no limits whatsoever, so I have none, I have the default value of these limits are none. So that is why I have not, well, if I had specified here an xlim value, then I would have the values limited by this interval, okay? But the other these other arguments, which are label, ls, and marker, these arguments that you can see, they are not written here, not label, not ls, not marker. These are not written here in the function definition. They have to be here in this part, okay? They are defined here in this part. If we call this function without this quarks argument, okay, if we define this function without these arguments and we call this function with this thing, it's going to return an error, but because it's going to say, okay, there are no label, not ls, and no marker keyword arguments, so what are you talking about? And that's it. So these quarks are being used here when I call the plot function. So when I call the plot function, it's like calling plot with all these optional arguments for the plot function, okay? And that's it. So this is what we're going to see about arguments, and after that I'm going to talk about the scope of variables. See ya!